although now I have a cough. All right, so here we go. Introduction to techniques in differentiation. So basically, in layman's terms, what this means is you're learning a shortcut today. So that is good news. Yes, woohoo. All right, so we have the constant rule, our constant multiple rule, we have the sum and the difference rule, and I skipped the power rule for just a second because this is really the most important one. Okay, so when we are taking the derivative of a constant, it is always equal to 0. Okay, and I'm going to show you why. What is the derivative? What are we using the derivative for? The slope, exactly. So if I gave you an equation, y is equal to 5, be very specific. What is that? It's a horizontal line. What is the slope of a horizontal line? 0. Okay, does that make sense? All right, so what is the derivative of 8?
0.
Oh, that would be 0, yes. Okay, I'm going to go back to this in just a minute. So this one, meaning our power rule, is probably one of the most important ones because it is inside every other rule that we do. When we talk about the quotient rule and the product rule, it is embedded in that rule. Okay, so this is one of the most important. And although it's written out for you, when you have your variable x, when you're taking the derivative, this coefficient will come down in front, and then this exponent will decrease by 1 degree every single time when you take the derivative. Okay, so when we're looking here, what I'm saying is this 12 will come down in front. You still have your variable, but now this degree will drop down by 1. So this is to the 11th power. Okay, so that is the shortcut. That is really the premise of the limit as h approaches 0 of f of x plus h and so on. Okay? Sorry. Constant multiple rule. So here we're being told to take the derivative of some coefficient times a function. So the coefficient is just going to stay there. You don't do anything with it. You don't take the derivative of it. You don't use the product rule, which some of you know, and right now you don't know it, so for some of us it doesn't mean anything, which is good. So for example here, we're being told to take the derivative of 3 times x to the negative 4th. So this is our coefficient. This is our constant. So ideally you're just leaving this. So essentially what we're asking you to do is leave the 3 and then multiply it by x to the negative 4th's derivative. So we would use this rule here. So this becomes negative 4x to the negative what power? Negative 5, yeah. So then obviously this gets simplified. And when you do these problems, it's not like you're going to be doing this every single time, but I'm just showing you the idea and the premise behind the rule. So essentially this is negative 12 over x to the 5th power. So there will be some occasions where it doesn't matter if you simplify a negative exponent, and others where if this is just a free response question and I'm asking you what is the derivative of 3x to the negative 4th, you should simplify. Negative exponents in the top go to the bottom, and from the bottom go to the top. You should always simplify. Okay, questions?
Sorry, could you go over it again?
The derivative? Or what I just said? Okay, so this coefficient, you leave it alone. You leave it in front. But essentially, whatever the exponent is that comes down, you're going to multiply them together. So I wrote it out right here, what you would do. Here's your coefficient, here's your exponent, here's your new exponent, and then I simplified. Okay. Again, as I said, the power rule is now embedded into, in this case, the sum and the difference rule. So here we're being asked to take the derivative of the sum of two functions, different functions. One is f of x, one is g of x. So here what this is just saying is take the derivative of f of x independently, take the derivative of g of x independently, and then of course if you were to have any like terms like constants, or maybe you had 2x to the second powers, you would combine any like terms. Okay, so for example, this is the sum. We're saying take the derivative, and I'll write it out. Basically we want to take the derivative of 3 plus the derivative, of x to the 1/2. Now, I would not expect you to write this out. Just take the derivative. So what's the derivative of 3?
0.
Yeah, it's 0. It's gone. The derivative of x to the 1/2 power will be 1/2 x to the negative 1/2. Okay, because I subtracted 1, which really simplifies to 1 over 2 squared of x. This derivative, next lesson, it's one that you're going to need to commit to memory. It's one of the most common ones that you will see very often. Okay? And then the last one is the difference rule, which ideally is the same thing as the sum, except now it's the difference. So again, you're going to take the derivative of these independently. So like I said, the only difference between these two is this is the sum and this is the difference. Okay, so since I wrote it out for the first one, I'm not going to write it out for the second one. We're just going to take the derivative. So what is the derivative of x to the negative 1/2? Negative 1/2. Yep. And then this is minus what? Minus 9. Okay, so that is essentially the derivative. If we simplified, this would become negative 1 over 2x to the 3/2 power minus 9. Don't even bother trying to get a common denominator. Jay, you okay?
Yeah, I'm just putting it together.
Okay. Well, we had to subtract 1, so you got a common denominator, 2 over 2. Okay. All right, questions before we continue with notation?
So why don't we say negative 9?
Because the derivative of x,
Oh, it's this one.
right, but the point is like when you're taking the derivative, this is 9x. Forget about the negative for just a second. This is essentially to the first power. So just like the one that I showed you, it's 9 times this 1 comes down, and then it's x to the 1 minus 1. So x to the 0 is just 1. Okay? All right. So first of all, there are an infinite number of notations for the derivative. And what you need to remember is that any variable can be used. There are variables and notations that are common and that we use often because those are the ones that we're familiar with. But you also need to be aware that, again, anything can be used. So a lot of times you're going to see things like f prime of x, g prime of x, h prime of x. You might have something like s prime of t. Okay, this is just indicating that you're taking the derivative. Here you're writing it in the notation where you're saying the derivative of y with respect to x, or the derivative of the area with respect to the radius, the derivative of the volume with respect to time. Okay, the derivative of the position with respect to time. I mean, there's so many different ways that you could write this. You could take the derivative of x with respect to y, dx, dy. I mean, a ton. Here, this notation is not one of my favorites, and I'll explain why in just a second. Y prime, g prime, x prime, h prime, t prime, f prime, whatever. The problem is if you're using pencil on a test, a quiz, or even on your homework, you know how sometimes when you're writing in pencil, it's a little bit light, so then we can't see the prime. So that's why sometimes it's easier or clearer if you write f prime of x, because then we're more prone to make sure that that prime is showing in between the variable and the parentheses. I'm not saying this isn't accepted, and I'm not saying you're never going to see it. Like I'm actually going to do it because of the notation in here at one point, but it's not really one of my favorites because sometimes we can't see the prime. So you just need to be very aware that you're making that prime dark enough if that's the notation that you're using. And again, this is y prime of x. I don't really understand why it's here twice. So then you would have f prime of x, g prime of t. It doesn't really matter. Okay, on this side, you're still being asked to take the derivative, but now it's written in the notation where the notation is more of a command. Like this right here is a command. Do you remember when I was talking about in the calculator when we put that in there and it had ddx? I told you it was a command to the calculator. It was saying, take the derivative of whatever I put in y sub 1, and this is where I'm putting this command. So if you have the derivative with, take the derivative of f of x, this is a command. Okay, and it just means take the derivative. Now, if you see the notation dy dx, that means the derivative has been taken with respect to x for y. So this is more of a verb. It's telling you what to do. This here also is the same thing. Take the derivative of f of x. So the way that you would know that this has been completed is f prime of x would be written, and you would say f prime of x is equal to. This is the same, except now this just has a sub x. Okay, again, there's so many. I mean, I could spend all day talking about it, but it's just really boring. Agree? Okay, that's what I thought. All right, so let's go through a couple of examples here, and now we're using the shortcut. We have now graduated from the limit as h approaches 0 definition, and now we can use the shortcut. So this is telling me to take the derivative of this function. The issue here is whenever you have a radical, it is easier to take the derivative if you write this in what we would consider a friendly form. And a friendly form, in general, looks like this, x to the n. So how could I rewrite the cube root of x in friendly form? That would be x to the n. Yeah, power of 1/3. So I'm just going to rewrite this. So this is d dx, 3x cubed minus 7x to the e plus x to the 1/3 power. So I haven't taken the derivative yet. I have to do it now. Quick question. E. Is it a variable or a number? It's a number, right? We're just using a symbol to represent the irrational value of e, which is 2.7 blah, 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 right? Just like we would use pi. Okay, so just kind of keep that in mind. So when we take the derivative, this becomes 9x squared minus, okay, you told me this is a number. I'm not asking you to write it out. I'm not asking you to estimate what it is. Just use the variable or the letter, the symbol that we're using to represent that number and bring it down just like you would. 7e x to the e minus 1. That's the rule. Okay, and this becomes what? Plus 1/3 x to what power? Negative 2/3? Okay, so essentially this here is my derivative. And if I were using this derivative to find the slope at a given value, I would stop here. But I would say often, especially to like in that circuit that you guys are going to do for practice, this is going to be simplified. So your answer is going to look like this. 9x squared minus 7e x to the e minus 1 plus 1 over 3x to the 2/3 power. Meaning I simplified that negative exponent. Okay, does anyone have any questions on A? You guys are good? All right, so let's take a look at B here. All right, we want to find the derivative of V with respect to R. Okay, so that we're saying that the volume with respect to our radius, or R, is this formula here. We just talked about pi. Pi is a number. Okay, and we use that symbol to represent that irrational number. So these here are both coefficients, agree? So when I take the derivative, what am I going to do with them? Nothing. I just leave them there, right? And then if I can simplify later, I will. So you can write this notation here, dv/dr, meaning I'm taking the derivative of v with respect to r, is equal to, this 3 comes down in front, so I'm just going to write it all out. 3 times 4/3 pi r squared. Obviously in your head you can simplify this, true? So if you just wrote the answer, which is 4 pi r squared, that's also fine. But that's the derivative. Okay, in this next problem, you need to understand conceptually what is happening. So for many of us, we have not learned the quotient rule yet, right? Okay, so in order for me to take the derivative of s with respect to t, I've got to deal with this fraction. So essentially what this means, if I'm going to write this in friendly form, this is s of t is equal to t squared over t plus t to the 1/2 over t minus 1 over t. I haven't even come close to taking the derivative yet. But basically what this is saying is I'm adding 3 things with the same denominator. and I need to simplify, which means what is t squared divided by t? It is t. So s of t is equal to t plus, is that t to the negative 1/2 when I simplify? Yep. And then what's this? Bless you. T to the negative 1. Remember, you want to get everything in the numerator. So this is minus t to the negative first power. So now this is all in our friendly form so that we can take the derivative. So I'm going to write the answer up here. So we've got s prime of t is equal to, and so I have enough room. What's the derivative of t? Right here. I'm looking at this one. It is 1. Okay? Then this becomes minus 1/2 t to what power? There's a box of tissues underneath.
Oh shoot, sorry.
Say again? Yes. Yes. Negative 3/2. Are you serious right now?
Am I stupid?
And then this is negative t to the negative second. Jay, are you serious? Bring it in here. Bring it here. Okay, also too, guys, we're all sick, and I'll tell you right now. It should be paused. It's paused.
Just add a
Still
little
going.
spice to it.
It's fine. They're gonna wonder.
Project.
Yeah, just
All right,
you got it, right?
yeah. Good note. I was
Okay,
supposed to
there
look
are.
at all.
That's the last box of tissues. So, if yeah, I mean we need them. So, all right, here we go. Let Jay do his unwrapping. Okay. All right. So where we left off. Here, we've got, I need to simplify a few things here. So my derivative is 1 minus 1 over 2t to the 3/2 power minus 1 over t squared. This is s prime of t. Okay, that's simplified. Now again, there wasn't a whole lot of space here, but this conceptually is important because you can't always use the quotient rule. Yes, did I make a mistake?
Wouldn't it be plus t?
Plus t. Ah, yes, I did make a mistake. Plus, thank you very much. Because this is negative. Yep. Right here, when I took the derivative, this negative 1 comes down, and I was supposed to make this plus. J threw me off. Okay, take a look at D. So, as I was talking about at the beginning of class, we don't know the chain rule yet. And sometimes, too, using the chain rule is not always the best way to do it. So, in order to take the derivative here, and we also want to evaluate the derivative at 0, I need to multiply this out. So, before I even get started, this is g of x is equal to x squared plus 10x plus 25. Okay, so this is my polynomial. It is in user-friendly form. So now I can just take the derivative. G prime is equal to 2x plus 10. Now what? Yeah. Plug in 0. So G prime of 0 is equal to 10. What does that mean? What does it mean based on what we've been talking about?
The slope has
Yeah, the slope of the tangent line at 0. That's correct. Of this function. Questions? Yes?
Wait, what happened to 25?
What's the derivative of a constant? 0. Yep. Any other questions? All right, so the other two you guys should be able to do on your own.